Hello everyone, I'm WebCPL and I'm about to give you a basic overview of complex numbers, as well as how are they written and how do we use them. So if you have never worked with complex numbers before, the complex numbers are defined as C. So what does this mean? Well, let's take the classic example, x squared equals minus 1. Now, there are no real number we can use here to solve this equation. It's basically insolvable. Now, what does this give the opportunity for complex numbers? It basically gives an extension to the real numbers so that we can now solve this equation. And the complex number is given as the letter I. And remember, it is a small I. So from what we can see here is that x equals the square root of minus 1. So this will basically mean that I squared equals minus 1. Let's take a basic look here. How do we usually write these complex numbers? We define them by the letter Z, and they are given by a real part called A and an imaginary part called B. So if I were to plot an example here, I have that the real part is given as 2 and the imaginary part as 3. So the letter Z, by definition, is given as A plus IB. So by knowing this, I can now say that Z equals 2 plus 3I. Now notice this little change. Before I had I before the B, but now I is written after B. And that is because when I is a concrete number, you write it at the end, and that is the basic tradition here. Now let's take up another thing here. It's called complex conjugate. The complex conjugate of Z is given as Z complex conjugate equals A minus IB. And if I were to plot this, it would look like this. So geometrically, what did I do here? Well, I reflected. What this basically means is you take Z, then you reflect it by 90 degrees down under the real axis here. And in particular, conjugating twice will give the original complex number. And by doing that, it would mean that the Z complex conjugate would equals the complex number Z. Now, let's take two more things that are really important when you're working with complex numbers. The first thing here is called argument. Now, when you basically look at it, what is the argument? Well, it is the angle calculated in the positive direction between the real axis and the complex number Z. So, how would I calculate this? How do we do that? Well, if you cannot see it directly, then let me draw it like this. If you still fail to see it, then let me do it like this. So what we basically have here is a right angle triangle. And like any right angle triangle, the basic idea of trigonometry also applies here. So that means that the argument of Z is an angle. It means that the argument of Z equals the tangent of B divided by A. Now, the final thing we're going to look at here is how do we translate this complex number Z into a real number. Taking a look at the right angle triangle once more, we can see that Z is given as the hypotenuse in this right angle triangle. So it basically means that the Pythagorean theorem of C squared equals A squared plus B squared. So what we get here is that Z equals the square root of A squared plus B squared. And the real number for Z here is called modulus. So that is a basic overview of the complex numbers and how we write them. I'm WebCPL and peace out.